This week on QDL, we continue our discussion on women in metrology, and we will be talking with Karen Malen-Hogle, an Associate Technical Fellow in 3D Metrology Engineering at Boeing, up there in Seattle, just up the road a ways from us, quite a ways, but still the West Coast. Karen has an amazing background at Boeing, having worked on the B-2 bomber, the 777, the F-22 fighter, and a whole lot more. And we'll hear how she got started in metrology in about 30 seconds. Join us then. Welcome back to QDL. QDL is your weekly look at who and what is making news in the world of quality. I'm Dirk Ducharme, Editor-in-Chief of Quality Digest. And as I mentioned, our next guest is a metrologist, a measurement specialist, who has worked at Boeing for nearly 30 years. She started on the B-2 bomber program using some of the first computerized theodolites. She worked on the 777 empennage, the V-22 vertical lift tilt rotator, and the F-22 fighter program where laser trackers were first introduced. Her areas of expertise are metrology processes, major assembly tooling, tooling for composite part assembly and tooling, additive manufacturing applications, and that's just a start. So, Karen Malen-Hogle, thanks for joining us today on QDL.
Thank you, Dirk. It's a pleasure to be here.
So that is actually quite a resume, and I realize that we've just barely touched on what you've done in 30 years at Boeing. But tell us, I mean, as a young metrologist starting off working on the B-2, I mean, that must have been pretty exciting. What was that like?
It was. I hired into Boeing as a tool engineer, and I didn't really know exactly what that was till I arrived. And it was an exciting time because Boeing had just purchased computer-aided theodolites, and so for the first time was transitioning to theodolites from standard type tooling. What made it really interesting is that back in the day, we used to load huge master gauges, which weighed tens of thousands of pounds, into the floor assembly jigs to set the locators. When theodolites came along, people didn't quite trust them, so they would load these master gauges and then take them out. We would shoot with theodolites, and of course the results were different. So looking back upon it, I'm sure it's because the master gauges were so massive that they deflected the locators on the floor assembly jig, but people didn't know that then. Everything was new and everybody was learning together. So those are some interesting times trying to convince people that, we weren't trying to schmooze them and that this new computer wasn't cheating the system, so to speak.
So, I mean, for those, a lot of our users now are if they're just coming into metrology or familiar with metrology, they know what, a laser tracker is or a laser scanner or so forth, but maybe a lot of them haven't actually used a theodolite. Why don't you describe what a theodolite is?
Theodolite's an instrument where we had to use 3 of them to triangulate to a point, so they're an angle measurement device. And because you had to have 3, and it also depends on your vision. So the standard joke is, hey, get the young person to come sight on this because they have better vision than people who are older and therefore more accurate reading on the instrument.
So a theodolite is kind of like, am I right, it's kind of like a surveying instrument. It's what you might see road crews using, right? Am I right about that?
Exactly, Dirk. It's exactly the same thing. It's just the ones we use in the aerospace industry have a tighter tolerance than the ones you see out on the road crew using, but the function is exactly the same.
Okay. Well, how did you get started into metrology? Were you always interested in, math and science and, building stuff?
Yes, I love math for sure, and I was thinking about going into math, being a math major in college, and my mom said, really the only jobs right now are actuaries, and they get paid a lot, but it's a boring job. I think you should pick an engineering field. And so I picked mechanical engineering, and that's my start in metrology, though, came at the Boeing company for sure. I didn't do any of that study in college, and it was really fun. I was on the metrology team from the start on the B-2 bomber program, learning with everybody else.
And so how did you transfer? I mean, so when you were in college, you weren't studying like, civil engineering or anything like that, right?
Correct.
Okay. And so you just kind of went from college, and your first job right out of college was Boeing?
No, I worked somewhere else briefly, but then I came up to Boeing because I wanted to live in the Seattle area. So when Boeing offered me a job, I thought, oh, I love airplanes and I want to live in Seattle. So this is a great opportunity.
So you must have been living someplace colder than Seattle already. Or
Sadly, no,
wetter.
I was living in Portland, which is about just as wet,
Okay.
but there was just something about the larger city that was appealing. And I lived in Portland all my life mostly. So I thought, oh, I want a new place to live and go. And they have airplanes there.
Well, we mentioned theodolites, laser trackers. What other equipment have you learned to use over the years being a metrologist? I should say a 3D metrologist. I mean, that's actually what you specialize in, right?
Right. For sure, the laser radar was as groundbreaking as the laser tracker was in its time. And I love the laser tracker. It's a very, very versatile instrument. The laser radar is really cool too, and I was able to work a project using it, and it's really exciting and fun. Photogrammetry is super fun. The arms, when they came out, they were one of the first instruments as well that we used, and everybody's just fascinated by it because they're so different than anything than a fixed CMM, right, which was the standard at the time for inspection.
You know, I come from, my background is electronics. And I know that back in the days, this would have been late 70s, early 80s, that you didn't run across, at least in the electronics industry, you didn't run across a lot of women engineers or even women techs for that matter. Mostly when you met women in electronics, it was very often on the assembly line. A lot of software programmers were women, so they were in on that side. But kind of on the technical end, I don't recall meeting many. So was that kind of the same true when you started off in your career? Were you kind of the lone woman out there surrounded by a bunch of guys, or were there a fair number of women in technical fields?
No, there wasn't. In fact, I was surprised when I started at Boeing how few women were in engineering. I went to a small college, Gonzaga University, and so we graduated 25 mechanical engineers that year, and 5 were women. So I thought, oh, 25%, that's pretty high.
That's pretty good, yeah.
You're right. So when I came to Boeing, it's like there was like 110 tool engineers on the B2 program and about 8 or 9 women, and so not a lot. And some of them did have civil engineering backgrounds, and
Yeah.
no, there were not a lot of women at the time.
Now, has that changed much?
No, it hasn't a lot. So,
And moving on.
yeah, right. There you go.
That's interesting. So you've been at this for a while, then 30 years, and we talked about you started with computerized theodolites. And there's been, equipment has changed quite a bit in those 30 years. What have you seen as the most interesting development in measurement equipment for yourself out there at Boeing, working at Boeing at your work?
It's hard to pick up one because the science behind each one is so different, and they're all really exciting, and they all have different applications to me. And what's exciting about working for a company like Boeing is the opportunity to work with all that equipment, that we're big enough that we can afford to buy all these different pieces and optimize for our processes. And sometimes we get to combine them. We might use a laser tracker and a laser radar in the same survey, or broken arm CMM and a laser tracker in the same survey. And so it's really exciting and fun to be able to incorporate those different technologies together.
Well, I was going to say, so you mentioned fun and using a bunch of different technologies. So what is this job like? I mean, is this very hands-on where you arrive in the morning and you walk out onto this enormous, place where they build airplanes and you start setting up equipment and lasers are zapping all over the place? I mean, what's it like?
It is for some. So we have a division of labor based on our union. So I get to use the opportunity to use the equipment in process development. But we have a group of hourly tool jig builders that actually run the equipment every day. So it's going out and watching them execute the survey, learning from them, seeing the techniques they use. And that's how I gained my experience, was just going out the shop floor and watching these people measure surveys on theodolites every day. And it was really slow and it takes a long time, but it's a great way to learn.
And what's exciting about this field? I mean, is it just the hands-on and doing something and seeing something being accomplished, kind of that sense of accomplishment, or is it actually the technology, or what makes it interesting? What makes it exciting?
For me, for sure, it's the fact that it's a high-tech field. Honestly, people measure every day, right? They don't even know it. They might be checking the tire pressure with a gauge, or they might be measuring something in their house to build a cabinet, and they don't think of it, and they don't know the word metrology, but everybody measures. Everybody measures almost every day, probably. And for me, it's the high-tech science behind it and the physics and how impressive it is, the technologies that these vendors put into developing both the hardware and software. It's just amazing.
And what advice would you give others who might be looking for a career, and you tell them what you do and they kind of go, oh, that sounds interesting, that sounds fun. What would you tell them about getting started down that career path?
First, when I tell people what I do and they go, oh, that sounds so cool, and I said, it is, but it's not the weather. And then they're like, oh, okay.
I always wanted to be on television.
Exactly, yeah. Newscaster. I would say to seek out the field. And so, right, it isn't standardized really well, and the job descriptions aren't, accepted by the Department of Labor as this, they still think it's kind of an up-and-coming field and there's not a lot of jobs in it. But I would say to specifically go look for jobs where you see this 3D portable metrology or metrology equipment or measurement or analysts or that kind of work, to look for that in job descriptions and type that into your job search.
Well, I was going to, you mentioned positions coming open. Boeing's a big place, so obviously you see a lot of people there, I'm assuming, retire, that sort of stuff. I mean, do you feel like the number of metrologists equipped to go into this is dwindling? I mean, are you having trouble, are you having trouble finding people who are skilled to come into this as the old timers retire out?
For sure, because there's still no colleges really. I mean, the surveying or civil engineering degree are the two closest degrees you can come to this field, and so it's still challenging because it isn't well known in the college level, or high school students don't think, oh yeah, I want to go into metrology, this is coolest, because they just haven't heard of it still, and they haven't been exposed to it. So we still need to do a better job getting the word out.
Well, yeah, I was going to say, so what kind of outreach programs do you think would be, or have you heard of, that would be beneficial in getting, like you said, getting the word out, so maybe high school students know that there is actually something out there called, metrology or 3D measurement?
I think taking an instrument out and showing an instrument live, because you can lecture all you want and tell about how cool it is, but really it's seeing an instrument in action. So it's taking an instrument out to the high schools or even the grade schools and saying, hey, look at this. This is what this can do. And have them go, wow, yeah, that is neat. That's really impressive.
Have you ever had a chance to do that?
I have not, but I have different coworkers within our company for sure that engage the high schools and go out and do, like CMSC, almost like an expo where they go and they're one booth there and they get to show the equipment and how it works.
Oh, that's cool. Did you have a mentor in this field, or did you just kind of go into it and start kind of learning on your own and learning the ropes on your own?
Correct. I just kind of fell into it by, of what I did as a tool engineer, and I took some off-hours classes from one of the jig builders who was a theodolite expert, and got started from there.
Oh, okay. Karen Malen-Hogle, I said that right?
Yes.
I'm really good with names. Well, thanks for joining us. I just think it's a fascinating career. I think working at some place like Boeing, where you have gotten to work on all these cool things. We didn't even talk about the F-22. I mean, that must have been, well, let's talk about the F. So what was the F-22 like? What did you do on that?
That was really exciting because we were able to implement a lot of really first-time processes, working with the shop floor in terms of setting really tight tolerances on some of the tools there, and actually being, for the first time, probably getting away from setting tools and setting production parts themselves, and eliminating that tolerance buildup between the tool and a part, and shooting and setting the parts directly.
And that was also using, I think you said the first time you used a laser tracker?
Laser tracker, okay. Correct.
Now, was that the first, one of the first laser trackers out there, or was that Boeing, first time Boeing had acquired a laser tracker?
It was like a Smart 310, so definitely one of the first trackers on the market. Boeing had also developed its own laser tracker called the BLT, the Boeing Laser Tracker. And so that was in the works in different parts of the company. But back in the day, before email and internet and stuff, it was a lot harder to connect different points of the company and find out what everybody else was doing.
Yeah. All right. Well, Karen, thanks for joining us today. It was really interesting, a fascinating career. And thanks for joining us today. Appreciate it.
Thank you for the opportunity, Dirk.
All right. Well, like Karen said, you know, the metrology career is an interesting career. If you've got kids or you're watching the show and you're interested, take a look at it. I mean, it really is fascinating because it is a very high-tech career doing 3D measurement of very large objects. A plane fuselage, for instance, and uses a lot of new cool tools. So check it out. I mean, I think you'd be really excited about what you can discover there, and tell your kids about it too. That might be something they might be interested in. Okay, well, that is it for today's show. If you have any suggestions for other topics that we should talk about, feel free to send them to us. You can send those to qdl@qualitydigest.com, and we will do our best to bring those people or those things or those topics onto our show and talk about them. So that is it for today. Thanks for joining us, and we will see you next week. So long.